Hello everyone, my name is Dr. Tejaswini Gurne, Assistant Professor in Department of Statistics, Rajarshi Chhatrapati Shahu College, Kolhapur. In last lecture, we see the sampling theory, types of sampling and one result. Now we see that the second result. In SRSWOR, the probability that a specified unit is included in the sample is n by small n. And the proof of this theorem is the specified unit will be included in the sample if it is selected at any one of the n draw. Therefore, the specified unit is included in the sample is the specified unit is selected at any n draws, and the probability of specified unit is selected at first draw, or it is selected at second draw or third draw or nth draw. So, we see that it is an independent event. So, or means the addition of all these probability. The specified unit is selected at first draw, same as the probability that specified unit is selected at the second draw. So, the probability is 1 by n. This is addition at n times. So, the final is small n by capital N, and hence this is the proof. Now, we discuss the next result. In simple random sampling without replacement, the probability of drawing a sample of size small n from the population of size n unit is 1 upon NCN. And the proof of this result is, we know that the simple random sampling without replacement of selecting first draw is 1 by n. So, in SRSWOR, the population size is decreases by 1. So, the probability of selecting any unit among the remaining n minus 1 draw unit at second draw is 1 upon n minus 2. So, the probability of selecting any unit of the remaining n minus small n minus 1 at the nth draw is 1 upon n minus 1. Since all these draw are independent, and by using compound probability theorem, the probability of selecting a cluster of size n is fixed with specified order is multiplication of all these probabilities. So, 1 by n, 1 upon n minus 1, 1 upon n minus 2 up to 1 upon n minus 1. So, since each of the cluster n unit which can be arranged by n factorial ways. By addition theorem of probability, the selecting clusters in any draw is n factorial and probability of all these value. So, simplification we get this. So, in numerator there is n factorial into n minus small n into n minus n plus 1 dot 3 into 2 into 1, and then denominator n minus 1 dot n minus n minus 1 and multiply by n minus n plus 1 dot 3 minus 3 into 2 into 1. So, the final term remaining is n factorial into n minus small n factorial divided by capital N factorial, and this is 1 upon NC n, and hence this third result is proof. Now, the next result is, in SRSWOR, the probability of a specified unit is included in the sample is 1 minus 1 upon n raised to n, and we see the proof of this result. We know that SRSWOR means simple random sampling with replacement. The probability of specified unit selecting at first draw is 1 upon n. So, therefore, the probability of specified unit is not selected at first draw is complement of this probability. So, it is 1 minus 1 upon n. Like that, similarly, probability of specified unit is not selected at second draw is 1 minus 1 upon n. Here n is fixed because the simple random sampling with replacement, the population remains same. So, probability of a specified unit is not selected at nth draw is 1 minus 1 upon n. Since all the draws are independent by compound probability theorem. and in SRSWR probability of a specified unit is not included in the sample, which is equals to 1 minus 1 upon n raised to n, because it has nth times. So therefore in SRSWR the probability of specified unit is included. So this complement of this probability is 1 minus 1 upon n raised to n. Hence the result is proof. The last result of this SRSWR is in simple random sampling with replacement. The probability of drawing a sample of size n from a population of size n units is 1 upon n raised to n. So proof of this result is, we know that SRSWR, the probability of selecting any unit at first draw is 1 upon n. Similarly, the probability of selecting at second draw is 1 upon n, and probability of selecting any unit at nth draw is 1 upon capital N. So all these probabilities are independent. So since all the draw probability of drawing sample size of n from this population size at n unit is, by using compound probability theorem, multiplication of all this probability and this probability at n times. So the final is term is 1 upon n raised to n, and hence the result is proof. For the next theorem we have used some notations. So first we see the notations. Capital N is number of units in the populations, or it is a population size. Y is the characteristic under study, or it is the observations. Y is the value of characteristics for the ith units in the populations, and the Y bar is mean, population mean. So the formula is 1 upon n summation yi, and n y bar means the population total. This is multiplied by this total of populations. So population mean y bar and population total n y bar are called as the population parameters. These two are the parameters. Now the small n is the number of units in the samples. This is also called as a sample size. Y is the value of characteristic for the ith units in the sample. The small letters used for the sample and the capital letters used for the population. So small y bar is the sample mean. Similarly, the n into y bar, like that the populations, here is the total mean. So see the result. So first theorems in SRSWR, the sample mean in unbiased estimate of population mean, like that is expected value of y bar is equals to capital Y bar, means sample mean is expected to be the population mean. So see the proof of this result. Consider expected value first. See the LHS of this equations. So we simplify this y bar is 1 upon n summation of y bar. This is the formula of y bar. So if we take the small n in outside of expectations, then this is the value becomes 1 upon n expected value of summation of yi, and the summation is also taken in outside, then this expectation goes in, so we get expected value of y, and expected value of y is, by using the formula, summation of yi into pi. So where p is the probability of selecting yi, this 1 upon n summation as it is, and this expected yi becomes, this is the formula of y bar. So n and this summation get cancelled, so we remains y bar. So expected value of y bar is capital Y bar. So therefore in SRSWR the sample mean is an unbiased estimate of population mean. So proof of this result. Now we see one corollary in SRSWR. N into y bar means it is a sample mean is an unbiased estimate of population total, means sample total is unbiased estimate of population total. So this is the corollary, not the proof. But next theorem is second theorem. And in SRSWR, the sample mean is also unbiased estimation of population mean. So that is the expected value of y bar is equal to I bar. Similarly in theorem first, but sampling is method is SRSWR. So proof of this result is same as theorem 1. The sample mean is y bar is equal to 1 divided by n summation of yi. So summation of yi is written as in the form of summation of alpha I yi. What is this alpha I? Where alpha is equals to 1 if y is in the sample and alpha is equals to 0 otherwise. So this simplification we get expected value of y bar is equals to e into 1 upon n summation of alpha yi, and get simplification we get 1 upon n summation expected value of alpha yi. But expected value of alpha I, what the calculation of expected value of alpha I? This 1 if it is in the sample, or it is 0 if it is not in the sample. So in simplification this formula get the equation expected value of alpha is n upon small n. So substituting this value in equation 1 we get expected value of y bar 1 upon n summation of yi. So this simplification we get 1 upon n into summation of yi is equals to y bar, that is SRSWR, the sample mean y bar in as unbiased estimate of population mean capital Y bar. And for this result, second corollary is in SRSWR, n into y bar is an unbiased into population total n into capital Y bar. Thank you.